Okay, just a real quick example of how you can do a titration math. I know the other video cut out. I'm so sorry about that. So the first thing we should do is write down the reaction. In the previous video, I already filled out the table, so I'm going to do that as well. 13.3, subtract 0.2, and of course that didn't save. Nope. Okay, that looks like our bad trial. Now the reaction that we're mixing is sodium carbonate with hydrochloric acid. It's a double replacement, but also a neutralization. So the hydrogens kick out the sodiums. We get H2CO3 and sodium chloride. Looks like we need 2 moles of that and 2 moles of that. Okay, going back up to our problem, it says, what was the concentration of hydrochloric acid? So question mark, moles per liter. Okay, in the table title, we are given 10 mils of sodium carbonate. And I believe what is the concentration of Na2CO3? Okay, so we're solving for the concentration of Na2CO3, and we're given, so I'm just going to move that over here. That's just a typo. And we're given the concentration of the hydrochloric acid, which is 0.144 moles per liter. Now, all of this table, we already have the volume in the question of this substance. So these good trials are the volume of the HCl. That's what we're titrating it with. So a quick average of these, adding these up and dividing by 3, 12.8 plus 12.8 plus 12.7 gives me, divided by 3, 12.77, sure. We'll go 12.77 milliliters. Okay. Now, since we're solving for, the other thing I forgot was mole ratio. I have 2 moles of HCl for every 1 mole of sodium carbonate. Okay. This is a solution-like problem. Since we're solving for concentration, I need the mole ratio first to get moles of sodium hydrogen carbonate on top. So 2 moles sodium hydrogen carbonate, or 1 mole sodium hydrogen carbonate over 2 mole hydrochloric acid. Because now I've got the mole on top. Okay, get rid of the mole hydrochloric acid with the mole from here, because that's mole hydrochloric acid per liter hydrochloric acid. Mole cancel. Okay, the last step is to use the volumes. I'm going to go 12.77 milliliters hydrochloric acid on top, because that is underneath hydrochloric acid. And I need liters of sodium carbonate on the bottom, so I'm going to use the 10 milliliters sodium hydrogen carbonate. Mils cancel, liters cancel. So you can see it's just like a stoic question with solutions where you go mole ratio, concentration, volumes. My final answer is 0.44 times 12.77 divided by 2 times 10 is equal to 0.092. Okay. So a couple pro tips. Usually a volume is given in the table title. If there's a volume given in the table title, that means the other substance's volume comes from the table itself. Don't forget to write a reaction, because that's where you get mole ratio from. And you should be given concentration in the table title as well. Throw out bad data, and we said watch out for things that are different than more, well, that's not writing right there, plus or minus 0.1. Really, if I included all 4 of those, I don't think it would actually change my number, but you never know. It's kind of bad too because the color is off. You'll see in some of the data from the lab, we were perfect. So you may not have to throw out any data. Okay, so that's a real quick crash course of the math for solution stoic.